his terracotta projects have included the downtown Nordstrom, the Dexter Horton Building, King Street Station, and the Arctic Building. Mark has written articles and given talks at professional conferences about terracotta restoration. And tonight, you will learn a little about architectural terracotta and the story of the Walrus Heads restoration on the Arctic Building. Mark Morton.
Thank you, Sherry. As part of this exercise, this project, I'm supposed to take questions from the audience. So I'm going to go through my presentation, my talk, and there will be a moment, or a point where I'll ask for questions, and then I'll be able to wrap up after that. So if you have a question, keep it in mind. But tonight, friends, I'm going to talk to you about the latest and greatest material in building construction, architectural terracotta. This material is an innovation. It's fireproof. It's cheaper than stone, it's lighter than stone, yet it can be molded and shaped like stone. It'll last for years, it's available locally, and you can get it in a variety of colors. This is going to revolutionize the building construction industry. Now, if you're an architect in the late 1800s, you might have heard a pitch like that from a salesman trying to sell this new product at the time, innovative product, architectural terracotta. Of course, nowadays, this is a historic material, but the buildings downtown that have terracotta claddings are some of the most unique and beautiful buildings we have in our city. Now, terracotta is a fired clay mixture. It's like brick, but it's denser and stronger than brick. Terracotta is molded by hand. They take the clay mixture and press it into molds. And it looks like a solid piece, but when they mold it, they actually create voids in the back and webs. This is a small piece, but bigger pieces have more voids, more webs in. This helps make the terracotta piece a little bit lighter. So when you see it, it's not a solid piece. Now, when terracotta is installed on the side of a building, there's two forces that have to be accommodated: gravity load and lateral load. Gravity load is what it sounds like. How is it going to stay up on the building? Well, terracotta, they just stack the pieces one on top of another, and periodically on the side of the building there's steel supports that hold it up. Lateral load is what happens in an earthquake or a strong windstorm. It's this movement, and you certainly don't want this falling off the building. So when they manufacture terracotta, they'll form in holes or slots, things like that, into which a steel wire or a strap engages the edge of the piece. And then that strap is anchored back to the substrate, the wall behind the terracotta. So it's like putting a little leash on the terracotta to keep it from wanting to tilt down. Tonight you have a very rudimentary understanding of terracotta construction. Here's the story of the restoration of the terracotta walrus heads on the Arctic Building. The Arctic Building, constructed in 1917, was the home of the Arctic Club. The Arctic Club was formed in 1908. It was a fraternal organization, and the common theme, the thing that brought the people together, was their involvement in the Klondike Gold Rush. So they constructed this building kind of as their clubhouse. The building is known for three features. One is in the ballroom. That's a Tiffany glass dome that is situated in the ballroom. It's pretty stunning if you're ever there to take a look at it. The second is polychrome terracotta, multicolored terracotta. This is the first building in Seattle that used multicolored terracotta instead of white terracotta. But of course, the main feature of the building are the terracotta walrus heads, which are located between each of the third floor windows on the two street elevations. So you have 27 walrus heads complete with tusk. Now, it was built in 1917. In 1982, there was a restoration repair of the building. As far as the walrus heads go, the tusks were replaced. Over the life of the building, the tusks had either been taken off or they'd fallen off periodically. And so at some point, reportedly in the early 1950s, they were all taken off. So the walruses became seals, I guess. So in the restoration, they restored the tusks, except these were not terracotta tusks. They were urethane, made out of urethane, and if this is the tusk, out of the top of the urethane was a threaded metal rod stuck up at the top. To install them in the walrus heads, because they couldn't take the walrus heads out to install, they had to somehow install these while they're in place. They drilled 2 holes in the top of the walrus's snout, then took the tusk, inserted in a socket on the underside of the walrus's head, and with that threaded rod in the cavity that's inside the head, they poured self-leveling grout through the top hole to fill that cavity, with the idea that the grout would then catch and hold that threaded rod and would keep the tusk in place. Seems like a good idea, and it probably wasn't. In 1996, late 1996, the building engineer happened to be out walking the lower roof on the back of the building. This is a little difficult to see, but he found there's 2 walrus heads here on this little return face of the building. He found the tusk of the last walrus head laying on the roof below the walrus head. So suddenly this was a red flag, and the building property manager said, look, we need to find out what's going on with all the other heads. So I got hired to come out and do an assessment. 1, find out the condition of the terracotta, of the walrus heads, and 2, figure out what needs to be done to fix it. So as I say, there are 27 heads on the building. We went out and looked at it, took loose pieces off so they weren't going to fall on people. And out of the 27, 13 of them were so badly damaged they had to be replaced. The others they were cracked and they had some problems, but they could be fixed. Now, this next slide, I'm going to warn you, is graphic nature. If you appreciate fine things, good architectural detail, this may be a little shocking, but this is what we found. It looked like this. So on this photo on the left, you can see these 2 spots here. That's where they drilled the holes to inject the grout. And on the right there, with the side of the walrus's head taken off, you can see the spout and then how the grout filled the cavity to grab onto the tusk there. We had the grout analyzed in a lab and found that it contained a lot of gypsum. Self-leveling grouts contained a lot of gypsum and other compounds that had reacted with the gypsum. When gypsum gets wet, one of the characteristics is it expands. So now you have an expansive material trapped in a confined space, exerting stress. One of the 2 is going to win. And unfortunately, it was gypsum, not the terracotta. It's also, it didn't just exert outward, straight outward, where we could, okay, well, we'll just fix these and no problem. It's exerting force in all directions. So ended up with internal cracks on the back side of the cavity, and they were just, it was in so many pieces it had to be replaced. The real tragedy is this. This is a detail from 1982, the original installation of the tusk. So you have the tusk here, here's the threaded rod, a profile of the head, and the grout. This was stamped special inspection required. The city required special inspection, make sure those tusks are going to be in place. It says here, proof load test each tusk with a 25-pound downforce. Anyone here can grab something and pull down 25 pounds of force. They could have just mortared or epoxied those tusks into the socket of the head without going to all of this. It was way overkill, and it led to the problems that I showed you. So now we do repairs on, there's some heads can stay in place, we do repairs, but the ones that have to be replaced, fortunately they're was that there is a manufacturer in Buffalo, New York that makes architectural terracotta, still makes architectural terracotta. So they made the walrus heads. Our problem was we have to install them essentially in this hole. We don't have access from the backside. When it's installed, we don't have access to the sides of the terracotta where the anchor holes and the strap locations are. So how do we get this in there without taking out a bunch of other material? As far as gravity loads, that's no big deal. It's just going to sit on this. It was sitting on it before, it'll sit on it again. It was the lateral loads that was the big challenge, because you put that big nose, snout heavy head in there, it's just naturally going to tilt. So how do we pull that back? Well, if I may say so, we came up with a pretty simple and ingenious solution. When the walrus heads were formed in the factory, we had them cast in holes in the back side into which a threaded rod could be inserted. So when it came out to the job site, see here, the contractor squirted some epoxy into the hole, put the rod in there, and that holds it in place. Then they make a template of the back side. They just take cardboard and cut a profile around there, mark where the holes were, and in that last slide, they put that template up there and they mark where the holes will be. And then drill those holes so that, and they're filled with epoxy, and then the head can be slid into place. And before I show you that, one of the other advantages we had when we replaced these heads is we could get to the back side. The tusks that were the source of all this damage, they were still intact. Urethane, they're not going to fall apart that easily. So we could reuse the tusks with the threaded rod coming up. But because there was access to the back side, the contractor could install that tusk and then just reach in and put some nuts on the threaded rod, holds it in place. So then this is the installation. Here he is injecting the holes with the epoxy, and then the head is lifted up. Those heads are about 300, 350 pounds a piece. Lifted into place, slid in, and then the straps hold it until the epoxy can set up, and then those rods have created the grab, or the leash, to keep that head from wanting to tilt outward. And then the joints are all filled in. So that was the challenge and the solution to our problem. And before I wrap this up, I will open the floor to questions. Yes, ma'am.
Did you send them one of the original heads to make a mold, to make the new one, to all the new ones to make sure they match?
We didn't send to them, they came to the site.
Oh, okay.
And they took their measurements and whatever they needed to do and could make their mold from that. And
okay. So they measured
make
the
the pieces.
original.
then- The thing with terracotta is when it's fired, it will shrink. So the scale is 13 to 12. So when they take real measurements, then when they make the molds, they have rulers that instead of being 12 inches, they're 13 inches, but they're divided like they were 12 inches, so that they automatically will get the dimensions right, accommodate the shrinkage.
Mark, the walrus heads are spectacular in their detail and their number. But I've always been curious, looking at the Arctic building, were the shields underneath the walrus heads always designed to be blanks, or were they meant to have some sort of family crest or other details to
No,
them?
just blank.
How'd you put the tusks onto the heads you didn't remove?
Those that we didn't remove, we didn't take the tusks off. Everything stayed in there. What we did, I didn't go into this part, but the grout that was in the heads that weren't destroyed, there's a potential that that grout would still be expanding and cause damage in the future. So we preemptively put some pins in the head so that when it did, if it did continue to expand, at least those pins would hold pieces in place until repairs could be done. Protect the citizens of Seattle below. If you go out there today, you'll see there's quite a few heads that need some work on because they did continue to crack. One more.
How long did the project take?
Let's see. It took us, we did our investigation first part of '97. By the time we had drawings and specs out, it was probably the first part of the summer. was done by the end of the year. The thing with terracotta is a lot of lead time, because they have a lot of orders, so you gotta get at the end of the line, and they produce in time, so it can take 4 to 6 to 8 months sometimes, so you have to build that in. But on this project, I think from start to finish was within a year. So my red light's on, so let me wrap up here. You learned a little bit about terracotta construction tonight. Hopefully when you're downtown and you see those white buildings and those multicolored buildings, you have a little bit of an appreciation for how they were put together and how special they are. They don't make buildings like that anymore, which is too bad, which is why we need to hang on to the ones we've got. So keep that in mind when you're downtown, and if you're ever in front of the Walrus Head, you give a nice salute.